This video is about the convergence and divergence of the improper integrals with infinite discontinuities. When is an integral considered an improper integral? A definite integral from a to b f of x dx is considered improper if either a equals to minus infinity or b, the upper limit is infinity, or lower limit a is minus infinity and the upper limit b is infinity, or if f of x is undefined or has a discontinuity at the lower limit at a, or discontinuity at the upper limit x equal to b, or at some number between a and b. Improper integrals with infinite discontinuity has a definition. Number one, if f of x is continuous on the interval a to b and has an infinite discontinuity at b, then the integral from a to b f of x dx will be written as limit c approaches b from the left, integral from a to c f of x dx. Number two, if f of x is continuous on the interval a to b and has an infinite discontinuity at a, then we write integral from a to b f of x dx equals to limit c approaches a from the right, integral from c to b f of x dx. Number three, if f is continuous on the interval from a to b except for some number c in the interval ab at which f has an infinite discontinuity, then you have to break it down. The integral from a to b f of x dx equals to integral from a to c f of x dx plus integral from c to b f of x dx. Then you have to check the convergence of or divergence of this one, first one. If this diverges, then you don't need to check the convergence and divergence of this one. So then the integral basically diverges. If the integral converges, this integral converges, and then you have to check this one for convergence and divergence. So if diverges, then again the conclusion would be that the original integral is divergent. So for this to be convergent, so both of these integrals have to be convergent. Once again, convergence and divergence of improper integrals. Improper integral converges if improper integral has a finite value. Improper integral diverges if the improper integral is either a minus infinity or plus infinity. So here are some integration formulas that might be useful. You have integral from e to au sine bu du, so you don't need to do substitution. You can just construct this formula. It will be e to the au over a square plus b square, parentheses a sine b of u minus b sine b of u plus c. Similarly, integral from e to integral e to the power a to u cosine bu would be e to the au over a square plus b square, parentheses a cosine bu plus b sine bu plus c. Integral of tangent u would be natural log of cosine of u plus c. The integral of cotangent would be natural log of sine of u plus c. The integral of secant would be natural log of secant plus tangent u c, and integral of cosecant would be integral from cosecant u minus cotangent u. Here's an example number one. So we are checking the convergence or divergence of this integral from 0 to dx over x cubed. As you can clearly see, the f of x equal 1 over x cubed is undefined at the lower limit 0. Because if you put 0 here, 1 over 0 is undefined. So therefore, we can say f of x has an infinite discontinuity at the lower limit of integration 0, and therefore integral is improper integral. So now we are going to check whether this integral converges or diverges. So we rewrite this integral from 0 to 2 dx over x cubed equals the limit b approaches 0 from the right. So we replace the 0 with a b, dx over x cubed. So now we have integral from 0 to 2 dx over x cubed. So we rewrite as a limit b approaches 0 from the right, integral from b to 2 dx over x cubed. Okay, now 1 over x cubed we have to rewrite as an x to the negative 3, so we can apply the power rule of integration. So applying the power rule here becomes a limit b approaches 0 from the right, x to the negative 3 plus 1 over negative 3 plus 1. Okay, we simplifying is your limit b approaches 0 from the right. Negative 3 plus 1 becomes negative 2, so we put negative here, and this becomes x to the negative 2, and indicate the limits b from to 2. Now we have to rewrite x to the negative 2 will be rewrite as 1 over x squared. So now we have a limit b approaches 0 from the right, negative 1 over 2x squared, limits from b to 2. So we write limit b approaches 0 from the right, and we substitute first 2 with the axis. So this becomes 1 over 2 times 2 squared. Keep the negative sign outside. Now we subtract, and we put the lower limit. So it becomes 1 over 2 times b squared. Okay, we simplify, so we will have a limit b approaches 0 from the right, negative 1 over 8, because 2 squared is 4, 4 times 2 is 8, negative 1 over 2b squared. Now we take this, find this limit. So if we substitute b equal to 0 where the b is, so we have a negative 1 over 8 minus 1 over 2 times 0 squared. Well, 0 squared is 0 times 2 is 0, so you have 1 over 0. And 1 over 0 is infinity, so now we have a negative 1 over 8 minus infinity. 1 over 8 is a very small number, so it becomes negative infinity. So you have a negative times negative infinity becomes positive infinity. So limit doesn't exist, so therefore we'll say improper integral diverges. So we have a special type of improper integral. The improper integral from 1 to infinity, 1 over x to the p converges for p bigger than 1, and diverges for p less than equal to 1. Improper integral from 0 to 1 over x to the p diverges for p equals to 1, and it converges for p not equal to 1. Comparison test for the improper integral. We have a function f of x and g of x, and they are continuous functions, and g of x is less than f of x on the interval from a to infinity. Then integral f of x converges. Then if this converges, then the smaller integral also converges. If this diverges, g of x in the smaller one, then the bigger one also diverges. So here you have x to the n e to the minus x, 0 to infinity, it converges for any positive integer n. So it is an example 2, integral from 1 to infinity, 1 over x, the square root of 1 plus 1 over x to the 4. So let f of x is 1 over x, the square root of 1 plus 1 over x to the 4. And g of x is 1 over x. Now the square root of 1 plus 1 over x to the 4 is bigger than 1. So this is bigger than 1, but this is less than 1. So this f of x is bigger than g of x, or you can say g of x is less than or equal to f of x. Now we have an integral 1 to infinity g of x dx, 1 to infinity 1 over x. Now here p is 1, so this integral diverges. Now since the smaller integral diverges, so the bigger integral also diverges. So we can conclude that this integral diverges. So here is an example 3. Integral from 0 to 1 over x minus 1 to the power 4. So first we check to see if anywhere the integral approaches plus infinity or infinity. Integrand. What is integrand? 1 over x minus 1 to the power 4. And this will happen where the denominator becomes 0. So we solve, take in the denominator x minus 1 to the power 4 equal to 0. So we solve so we can get x equals to what? 1. And this 1 is between 0 and 2 in this range of integration. So now to deal with this, we break the integral into two integrals. So integral from 0 to 1 over x minus 1 to the 4 dx. That becomes 0 to 1, 1 over x minus 1 to the 4 dx plus 1 to 2, 1 over x minus 1 to the power 4 dx. So first we check the first integral and let's compute this one. So to compute this one, we rewrite this integral as limit b approaches 1. Integral from 0 to b. So we change 1 to b because where there is a discontinuity. And we rewrite 1 over x minus 1 to the 4 as x minus 1 to the power negative 4 using this negative exponential rule. Now we apply the generalized rule. We just add 1 and divide by. So you will have limit b approaches 1, x minus 1 to the negative 4 plus 1 over negative 4 plus 1. And now we indicate the power 0 to b, limits to 0 to b. Now we simplify, and negative 4 plus 1 is negative 3, and negative 4 plus 1 is negative 3. We apply the negative exponential rule, and so now we have a limit b approaches 1 over negative 3x minus 1 cube, and limits 0 and to b. So now we can factor negative 1/3. So we have a negative 1/3 limit b approaches 1 over x minus 1 cube, and limits 0 to b. So first we substitute x equal to b, and so we will have negative 1/3 limit b approaches 1 over b minus 1 cube minus 1 over, and then we put x equal to 0. So it becomes 1 over 0 minus 1 cube. So now we rewrite negative 1/3 limit b approaches 1 over b minus 1 cube, and we can simplify this to, well, 0 minus 1 is negative 1, cube of negative 1 is what? Negative 1, and you have a negative, this make a positive 1. So now we find this limit, so we substitute b equals to 1. So now we have a negative 1/3, 1 over 1 minus cube plus 1. 1 minus 1 is 0. So we have a negative 1/3, 1 over 0 plus 1. 1 over 0 is infinity, and infinity plus 1 is infinity also. When you multiply a negative number, it becomes negative infinity. So now since the answer is negative infinity, so we can say limit does not exist and the improper integral diverges. There is no need to check the second integral 1 to 2, 1 over x minus 1 to the 4 dx, because one of the two pieces of integral diverges. So we simply say that the given integral diverges.